Everybody, my name is Darryl Salas, VP of Americas at Hopsworks, joined by Fabio Buso, VP of Engineering and co-founder. And we're here to present our medical Copilot and product lifecycle Copilot applications. We'll start out with medical Copilot and the problems that we're trying to solve. We're trying to make healthcare providers more efficient and more effective. And the problem that they encounter is information overload. So using the Copilot, we are trying to alleviate this information overload. And we're very successful at doing that because information overload comes from the fact that every patient has tremendous amount of information associated with that patient, especially over a lifetime. And a lot of that information can easily fall through the cracks because it's stored in multiple systems and just because of the sheer volume of that information, even for a single patient. And second of all, there are a lot of best practices and standards associated with the different um, stages of the treatment life cycle. And at every stage, there are going to be generalists, overall generalists that are treating patients. And then even within a specialty, there'll be less experienced or more generalists within that specialty because every specialty can get further specialized as you drill down. And so a lot of best practices and standards can be overwhelming and fall through the cracks. With our Copilot, nothing falls through the cracks because we're using a combination of standard business intelligence combined with artificial intelligence and machine learning to digest and analyze all the information, every piece of information, so that we can provide healthcare providers with better insight. And then the second part of what the copilots do is that uh, it helps create documentation and it helps create treatment plans, which are tedious to write. They're very time consuming. And um, to do a thorough job of these treatment plans, not only do you need to take into account a lot of information, but also structures, treatment plans, and standard naming conventions to make them more easily digestible. So our Copilot, medical Copilot, does all these things and has tremendous results. And so um, what we're doing to get these results is, like I said, the combination of business intelligence that relies on structured, trusted data, uh, and adding artificial intelligence and machine learning to it. So the machine learning for medical records, we're using a deep learning model that can classify. It's one of the components in the Copilot. And then we're also using a large language model, and we're grounding uh, where we use the large language model in structured data from either our online store or also from the vector using a vector index that we can use to help ground the large language model. So everything is personalized uh, based on a context that you're looking at. So the context panels that we have here are based on the treatment life cycle. And so we have personalized at the patient level, at the condition level, at the provider level. All the personalization information goes into getting accurate answers to these kinds of questions. We started out with a bunch of starter questions in plain English that are very common questions that our customers just with that, and that will get you a jump start. It's all plain English. You can copy these questions if you're using the Copilot, paste it into the chat, paste them into the chat bot, or you can paste them in and modify them. So it's not like a standard BI tool that you have can parameterize questions that have like question builder and you need a lot of training. It's just plain English. There's very little training involved. And as I mentioned, we're combining the best of both worlds, BI and artificial intelligence. All the information is available in the Copilot for making better decisions, and we're all the best practices as well. And this is you know these are the different questions that you're going to see in the chatbot. If you're a user, very like I mentioned, plain English. These are the different life cycles. This is going through the different life cycles, and then we have a behavioral insights set of questions that rely almost exclusively on a graph database. In this case, Neo4j, such as the patient journey questions, looking for patients that are similar journeys that other patients have had with respect to a particular condition, for example. So we're combining a lot of different data layer technologies into Copilot. And so here's the kind of questions that we're asking in the Copilot. As I mentioned, the medical image questions, um, structured data type questions, and and then on the right hand side are the technologies that are being used to answer these kinds of questions. So we're using function calling in RAG for tabular data and also for the graph data. So we're using Lang graph in this case for the Lang for the um, LLM toolkit. Monet is we're using to classify the data. We're using a vector index to find similar journeys, similar conditions, and we're using a generalized LLM. We're not using a specific LLM, but you can use one or more than one LLM in the platform. So, for example, you might have a generalized LLM to answer the questions, and then a larger LLM for fine tuning, and then the conductor orchestrates everything. And then we get asked the question like, how do we know that the answers are accurate? And first, there's the eyeball test. The eyeball test, they look very accurate. And then, second of all, you can um, you can modify the prompts. So with as you go along and look at the answers, you can do prompt engineering is one technique, and then the other technique we would call it the last result is fine tune. Resort is fine tuning the model. All of these things are possible in our platform, and our platform makes those relatively easy to do. So PLM Copilot, very similar, but a different use case. We're trying to accelerate time to market. So when you build products, you want to get it out to market faster, eliminate bottlenecks, and handle a lot of the tedious tasks, such as creating user stories and any kind of documentation. And same technology under the covers. These two solutions we built in 2 to 4 weeks, and we're building other solutions similarly based on our platform that makes it easy to build these solutions fast and get accurate results. So Fabio is going to show you a demo, but again, this is the same slide as before. What components we're using? We're using function calling, RAG, a vector index, generalized LLM, and then a Hopsworks inductor. And the personalized type of information in this use case is company information, department information, standards, best practices, policies, and procedures. Very similar to the personalization information that we're using for the vector index in the medical Copilot. And then here's a screenshot of what the chatbot, some of the context panels in the chatbot. I'm going to hand it over to Fabio for the live demo.
Okay, thanks, Darryl. So we can start by looking at the Hopsworks Medical Copilot demo. So the idea here is, as I was mentioning, is that you're a medical professional and you want to diagnose a patient, essentially. So we built and leveraging Gen AI, a tool that helps you sort through all the patient history, detect and diagnose the condition based on X-rays and other type of documentation, as well as doing analysis on patient history and compare that patient with other patients, right? We leverage different technologies. We leverage our online store for the real-time retrieval of structured data. We leverage vector index for retrieving relevant information. That could be documentation, could be guidelines, could be best practices, as well as Neo4j to be able um, to detect patient journeys and compare patient journeys and so on. Right? So the first thing you want to do to get started is basically looking at the patient results of the first exams, right? So the patient shows up. So this is my X-ray. So this specific demo pulls the X-rays around the chest area to be able to detect what's happening on the X-ray. We're actually using a model from the MoneyEye toolset. And MoneyEye is a set of models that have been trained by NVIDIA and some of the university partners. Um, and it basically trains to different set of models. We're using one for the specifically for the chest X-ray that basically detects around like 10, 12 different conditions, everything from fractures to heart conditions, to lung conditions, and so on, right? So what we're doing here is we're leveraging the upstream conductor and we're leveraging the LM and the function calling to be able to create different resources to be able to come up with a conclusion, right? This specific case, we're asking the LM model to be able to make a prediction, and then we're feeding that prediction into the LM together with the application report, and we are asking the LM to summarize the results, highlight what are the most likely causes, also highlight any kind of discrepancies between what the model is predicting compared to what the application report is actually saying, right? And then what are the kind of the key points and so on, right? So this is kind of the first step to kind of start looking at the case. So that stuff in the case have been the base. Obviously, that's not enough to be able to make a diagnosis, right? One of the key aspects of what I'm being we want to know information about the patient. So one thing you can do is ask the chatbot, say, tell me everything I know about this patient. What's happening behind the scenes is that the LM is going to the Hopsworks online store to be able to retrieve all the patient history that's been accumulated, right? So we're using a file format called FHIR, FHIR. We're ingesting those files. Those files contain information about all the patient's interactions with the medical system, everything from doctor visits to tests to even insurance claim, insurance interactions. Also, we have first pipeline that basically removes some of the non-medical stuff from the dataset, and we basically make it available for the LM to create it. And then what the task the LM is actually asked to do is basically given all the history, and I chose patient number one here, as specific as I know I told them like 93 years old. It shows that patient, and we asked the LM to basically summarize the LM and come up with like different aspects, like what are the information since the last visit, changes in trends, what are the risk factors of the specific patient, and things like this. So, from a doctor perspective, especially if you have a lot of patients, and so we kind of help people to help doctors to be able to um, summarize all the information, gather information from all different data sources, and present it all these medical systems and present it in a single way. In these examples, we bring together the information from the X-ray, and the patient from the X-ray with the medical history and so on, right? And this is kind of the power of the Copilot. We also can look at things like, look at the patient journey, for instance, right? So for this question, again, same idea behind the scene, leveraging the LLM to be able to invoke different toolings and using function calling. One of this set of toolings allows the introduction with Neo4j. And that specific case, we were looking for is patterns in different interactions that the patient has had with the medical systems, either for a specific patient, specific diagnosis, like in this case. I was looking at the specific condition, which is acute bronchitis. The patient is a kind of different encounters that the patient had. So in this case, we got admitting to the emergency room, and we can also track things like if they've been obviously with the power of like the graph, we can also see if a condition has kind of regressed or the condition was cured, but then it fall back to the same condition, we can track that information essentially, right? And basically look at different items that you can see basically, right? So um, those are kind of the capabilities of analysis that the Copilot has, looking at different sources, bringing them together, but also as capabilities to kind of like assist um, the the, um, the medical professional to kind of make the diagnosis, right? So for instance, you can look at given the information you have so far, so given the patient history, given the result of the X-ray, what is the most likely cause, and what are the obviously the supporting evidence, if there are other tasks, other exams that we can do to actually um, um, we can actually confirm that diagnosis and so on. As well as based on the treatment plan, based on the medical data, based on the case, based on the diagnosis, we can uh, ask the Copilot to come up with a specific treatment plan, essentially, right? And again, this kind of uses very basic LLM, but all the power is basically in the grounding aspect and basically bringing in all the concepts from structured data, graph data, and structured data. Again, this is kind of some examples of different conditions the patient is suffering from, and kind of some of the options in terms of treatment plan that the user has, the doctor has. So this is the medical Copilot demo. And we also have a demo for the product lifecycle. So this is a totally different field. Here we are focusing more on product development. That could be software development, could be physical product development. In this example for this specific demo, I've loaded in data sets coming from the Apache Foundation. So we are focusing on the software development side, but this can be extended. Anytime I mention something like a Jira ticket, you can think it about like you can think about like a ServiceNow ticket or you know other ticketing system that you might use in different areas of the business. Right. So the first thing you can do in the Copilot is basically ask the Copilot to come up with stories for you. Right. So write me a story or other videos. Right. So this is a very high level task. Obviously, what I said earlier, we've loaded the set, which is part of the Apache Foundation, specifically the Apache Kafka project. And the zero set is actually built on different things, right? Obviously, we have all the tickets of that project, as well as things like documentation, the public documentation, as well as things like um, the design document and things like this. So we have a mix of again structured data, unstructured data, and rough data, right? So in this specific case, I like this example because we can leverage all three of them. And we look at the structured data, so we basically want to retrieve from the vector index all the information, all the like critical aspects, for instance, or from product requirement documentation and discussions that have happened in the ticketing system, to be able to kind of define what are the critical, what are the key aspects we want to give to the LM to be able to, come with a good story, essentially, right? The second thing that we do is we want to look for existing stories, right? And for that we use Neo4j, and we want to look for similar stories in the past, not only similar stories in the past, but also related tasks. So we want to we have basically loaded all the tickets as a code, and we basically clean that so that we can find all the tasks, all the relevant tasks. If there's a new functionality implemented that's caused some bugs, we're going to detect that and we're going to include that in the prompt. So the LLM can figure out, obviously use that information to do what are the potential to inform the user of potential challenges that they might encounter when implementing new functionality, or as also what are the related issues that the user can go and look out for inspiration. So the last item that we include in the prompts is more of structured data. So we basically have pipelines in the background that basically compute averages in terms of time mistakes for tickets to be closed based on different teams and based on different ticket sizes, so that we can keep an average there. We ask the LLM to come up based on all information with sizing prediction, and then based on that, and based on the performance of the teams, we can kind of give an estimated hours how long that thing is going to take. Right. So this is a pretty starting point. You take that information, you bring it to sprint planning. You can refine it with the team. You can refine the subtasks. You can obviously discuss the challenges and things like this. You kind of have it like a structured way, right? This is kind of generation aspect. We also have in the Copilot itself a more like analysis of the project. You can ask the LLM what's the status of different projects. We can leverage the same sources. And we can ask the LLM to kind of have information about specific work items. And we tracked two specific items. So one is the duration, two metrics, sorry, the duration and the priority. So in this case, again, the way the Copilot works is that behind the scene, we have a set of templates of queries that we have basically created. And we ask the LLM and then use those templates and fill in the relevant in terms of which sprint we care about, which work item we care about, which metrics we're caring about. And based on those input, that's basically the query, I guess, issue, I guess, specifically the guess issue again. That allows us to focus the LLM on specific items and not the LLM wander around and create like some random queries, but actually focus the LLM on those specific queries and allow them to kind of customize them from starting from us. So it's a solid foundation. You can also go a little bit more in detail, so you can look at things like, for instance, okay, I want to look at this specific sprint, or I want to look at more structured information, for instance. Look at things like what is the average work item and priority for this specific thing. So this is more of a structured query. We look at different averages and so on. We present it in a different way, depending a little bit on the question itself. So these are the two demos. Thank you very much for listening, and I think we can take questions now.